Okay, so this is your second ed puzzle for the year, but this is your first ed puzzle for this unit. And we are in Unit 3, and we're going to look at finding ways to solve the arctangent, arccosine, and arc sines of things. Basically going backwards to see what is the angle from them. We've already started to discuss this. Now, this first problem says same signs but different signs. Okay, so what I'm trying to do is determine from reference triangles that you already see drawn. It says the terminal side of the rotation angle A. So it's like if I created an angle here from my original 0 degrees, and I have my terminal side being A, and I want to show that it passes through this point of negative 4,3. Okay, so negative 4,3 is right here. And I want to evaluate what is the sine there, what is the cosine there, and what is the tangent there. This is basically saying what is the y value there, what is the x value there, and what is the y over x value there. Now, something to remember is I need to be quadrant specific because some of these quadrants will have different signs. And we know that from the unit circle of negative positive, negative negative, positive negative, and so on and so forth. So I created a reference triangle, which we've already kind of done, and it's showing that it's going to go through this point of negative 4,3 right here. Now keep in mind, my angle is still here that I highlighted at the original start of this video. That's my terminal side rotation angle of A. Okay, so what we want to do is we want to find the sine of A. And the sine of A is just going to be what is the y value right here. So you see I drew a reference triangle, and quadrant specific it shows that it's going to be left 4, so a negative 4, because like here would be my origin. And it's going to have a y value of 3, and then always, 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 like we discussed in class, my radius is going to only be a positive value. So sine is opposite over hypotenuse. So we have opposite over hypotenuse. This is how we get 3/5. Look at the cosine. The cosine is basically the same triangle, but this time I'm going to look at what is the cosine value. So the cosine is from where I'm at, it's going to be the adjacent over the hypotenuse. This is how we get the negative 4/5. And then the tangent. From this angle, it is going to be just the opposite over the adjacent, which is how we get the negative 3/4. Now, I know that the angle that we started with is here, but here's the thing. That angle, because it terminates and goes through negative 4,3, is going to be the same if I were to do this as a reference triangle and then do it quadrant specific. Okay? So we will get to that here at the end of this video, and you'll see what I'm talking about. Let's do my next example. It says the terminal side of the rotation angle B. So this time we're going to use the angle B, and the terminal side is basically, it's an angle that's created still from 0 degrees, and it's going through B. Now this one is more so of a reference triangle because of the fact that it's in my first quadrant, and it has this positive, or basically this less than 90-degree reference triangle. Okay, so here's my angle, if you will. And here, right here, that I just put this dot here, is my origin, if you will. Similar to that. So the triangle that I have, and it goes through positive 4, positive 3, this one's going to show that it is a positive 4, positive 3, so showing in quadrant 1. If I took the sine of this, it's only going to be the opposite over the hypotenuse. We get 3/5. The adjacent over hypotenuse would be 4/5, and so on and so forth, 3/4 for my opposite over adjacent tangent of B. So which trigonometric functions yield the same for both rotation angles? Well, in this case, the one that yields the same will be the sine values. This y value is the same sign as this one. So that's what we're talking about as far as same signs but different signs. Okay? These are the same signs as far as positive and positive. So we'll say the sine or the sine of x. And then with the calculator, what we're going to do is we're going to find what is the arc sine of that 3/5. So like we're trying to find what angle A is if we were to solve here, and solve what angle B is if we were to solve here. Alright, so let's go ahead and take the arc sine of 3/5 with our calculator. something that I want to show you right off the bat is if I press 2, menu C, whoops, not D, menu C, and then I press OK, OK, which it won't let me do because I have the program software on the computer, it would put you in default mode of radians. Now, the settings button here, either pressing 5 or going to 5 and pressing enter, you can press 5, whoops, let me go to my home screen. I can press on this and then I'll press document settings. This is the angle right here that I want to make sure that you know how to convert back and forth to radian and degrees. I'm going to convert this to degrees right now, and I'm going to make it my default and press OK. So that when I go and create a new document, I'll say no to unsaved changes, I'll add a calculator, and then control add page, I'll add a graphing calculator. So let's go ahead and go to my regular calculator screen, and we're going to solve this arc sine of 3/5, and it's a positive 3/5. So I'll go to arc sine, I'll press control divide, and I'll have 3/5, and then I'll press enter. Now you see it's going to repeat and show me the same exact thing. Something we need to get used to, let me copy that, is pressing control enter. That will give you the actual value in decimal form. So it's going to give you quantitative value with decimals. So you see it's about 37 degrees, which is what I already have written down. So about 37 degrees is positive. So we're going to show that this is going to be angle B because it is in quadrant 1. So we call this the reference angle. So how do you think we could find the measure of the other rotation angle? Well, we know from here to here is pi, otherwise 180. And if I were to subtract this piece right here, which I know is mirrored over here, I would be left with what is this angle here, which is 143 degrees. All right, something to remember also. I know we've gotten ahead in as far as been exposed to what is the domain of arc sine already. We know it's between negative pi over 2 and pi over 2. Well, that's why when I put it into my calculator, it doesn't spit out the answer of 143, calculator-wise. Even though it is an answer, it doesn't spit it out. It spits out 37. And the reason of it being is because 37 falls right here, which is between negative pi over 2 and pi over 2. All right. So the first one we went in depth. The next one we're just going to do a practice, and we're going to go a little bit faster so you can see of how everything applies. All right. So the terminal side of a rotation angle, okay, is going to go through the angle A, or passes through A. So here's the angle, and it's going to pass through A. And what's created as a reference triangle, again, remember that's where the point that you ended up at, you draw a straight vertical line to the nearest x-axis, and then a straight line to the origin. That's how you know how to draw your reference triangle. Okay, and labeling it depending upon the coordinate that we were given of negative 4, 1 shows I'm going to have a negative 4 and I'm going to have a positive 1 because this right here is where my origin of the xy Cartesian plane is. Okay, so solving this immediately like a trigonometric or a Pythagorean theorem, I'll have a squared plus b squared, which is 1 plus 16, which would give me 17. When I take the square root of that, I have the length of my c value, or my hypotenuse. So from where I'm at, I'm going to do the sine. Again, the sine is the y value, but because we don't have any unit circle reference as far as my radius is 1, I do have to do this as a reference triangle, so I'll do the opposite over the hypotenuse. Rationalizing the denominator gives me root 17 over 17. Okay. Now let's do the cosine. The cosine will be the adjacent over the hypotenuse, which is going to be rationalized negative 4 root 17 over 17. And then finally what you see is the tangent. The tangent is the opposite over the adjacent, which would give me that 1 over negative 4 or negative 1/4. So let's go ahead and do where it goes to the angle of B. So again, here's the other angle, and it's going through B. It's going through that negative 4, negative 1 point. So if I were to look at that, immediately you see that I drew the reference triangle right here, and here's my origin, if you will. I'm in quadrant 3. I'm in quadrant 3, so it has a negative x and a negative y value. Still doing Pythagorean theorem, again, we'll have my hypotenuse, or otherwise radius, is always going to be a positive value. So from there, I will again go through the process. It will be, let me take this off so you can see it visually. It will be sine is opposite over the hypotenuse, which rationalized would give you that. The cosine is adjacent over hypotenuse, which would give you this rationalized answer. And then opposite over the adjacent would give you a positive, because a negative over a negative is a positive, which is what you're going to get a 1/4. All the while, please remember that this is quadrant 3 that you're working with. All right, so which trigonometric functions yield the same value, basically the same sign? Well, this one, looking at it, is going to be the cosine. The cosine are the same values, okay? Otherwise, we just say cosine of x. And then with the calculator, what we're going to do is we're going to see what is the arc cosine of this ratio side value of -4 over root 17. Now, let's go to the calculator. We'll say, what is the arc cosine? We'll say control divide, so we can have our nice little fraction. We're going to put -4 over root 17. So -4 over the square root of 17. And again, you're going to get a weird answer if you don't get accustomed to pressing Control Enter. So we got to get acclimated to pressing Control Enter. We get 166 degrees roughly, and it was a positive 166. Okay, so what does that mean? Well, that means that when I put it into my calculator, it gives me this answer. And why does it give me that answer? Well, the reason of it being is what we've discussed. The domain of arc cosine is from 0 to pi. So it's not going to give me this third quadrant, -166 answer that you see here, that we know would be even as far as positive 166 and -166. And we've talked about this as far as reflecting over the y-axis as the other graph, as far as the wavelength and the parent function of cosine, which looks like that, so on and so forth. Because of the fact that this is even, this will reflect also on the unit circle. Positive 166, -166. Okay, so let's go back to the reason why it will spit out a 166 is because of the fact that it is in this domain of arc cosine. So that will yield that angle of A. How do you think we could find the measure of the other rotation angle? Well, we know that that is 166. That means this little sliver here is going to be 14 degrees. Well, because that is, and we know that these two, top and bottom, are the same, if I added that, I could say 2 times 14 plus the 166, I could get 194. Okay, so 194 is, if I were to go from here all the way to B, which is coterminal with -166, if I were to just go here to here. The reason why I would say -166 though is because of the fact that I'm trying to stress to you is that cosine is an even function. Okay, so this I would prefer, but this would still be okay because of the fact that they are coterminal angles. Let's go to our third example. So now I go through the point -1 and root 3. So -1 and root 3 is here. Looking at that, I create my triangle quickly. Again, this is my origin reference. I have a -x, positive y, always a positive hypotenuse, and we'll go straight to the sine, which is the opposite over the hypotenuse. You get that value. We'll look at the cosine, which is the adjacent over the hypotenuse, which is -1/2. And then finally, we'll look at our last one, which is the opposite over the adjacent, which would just give you that -root 3, or -root 3 over 1. So you're getting the pattern now as far as how these reference triangles have been constructed all this time. Now this is in quadrant 2. This one is in quadrant 4 because we're starting to progress to that. And we know that this one goes through one negative root 3. So again, it goes right here, which you will see that I'm going to also write it there so you can see what it looks like as far as being in quadrant 4. And then from the center origin, I'm going to look at that and say, well, what's sine from where I'm at? Well, it's going to be the opposite of the hypotenuse. That's how you get this value. The cosine will be the adjacent over the hypotenuse to get the 1/2. And then last but not least, the opposite over the adjacent would again give you that negative root 3. Well, you should see now that these tangents are the same value. Okay? So it is the tangent or tangent of x. And then with the calculator, if we were to solve what is the arctangent of root 3, let's go ahead and do that real quick. So the arctangent of, what was it, positive root 3. So root 3, whoops, root 3, control enter to remember that, I get 60. So 60 is, let me go back, I get a 60 degrees. So I get a 60 degrees because of the fact of, I just realized, I made a mistake, it's not the arctangent of root 3, it's the arctangent of negative root 3. No worries there. So I will go again and say the arctangent of negative root 3, control enter, and I get negative 60, which is the answer that it should have yielded. Because negative 60 is this one. The other one would be, well, since this is negative 60, let's figure this out unit circle wise. We know this would be 60 because reference triangles, they're both 60. So 180 minus that 60 would yield that this angle here is going to be 120, which is what you see already written down. Okay, so 120 or negative 60. Why does the calculator spit out negative 60 and not 120? Because of the fact that the domain of the arctangent is between negative pi over 2 and pi over 2, so it would spit that one out. Because 120 doesn't fit in that domain restricted value of negative pi over 2 to pi over 2. Now, here, something to introduce is collinearity. If I were to say negative 60 and I added 180, I would get 120. We're going to look at this here soon because it's going to yield different answers over and over that we're going to look at that deal with the arctangents. Okay, the cosines didn't necessarily create that. If I were to go back and show you on a unit circle, I have 166 and 194. They don't create that line, if you will. As you can see over here, there's not a line amongst this that shows both answers. They're not collinear. The same with the arcsine. They're not collinear. They're on two different lines as far as on the graph and on the unit circle. Whereas the tangent, they are collinear. Just something to introduce of what we're going to get into here in just very soon. While sine, cosine, and tangent are functions, their inverses are not. We talked about this yesterday in class as far as them not passing the horizontal line test on their original function and how it translates to only certain parts of the graphs being shown on their arc or inverse functions. So this means that when solving an equation using inverse trigonometric functions, a calculator may not provide the angle measure that you seek. You have to find it. So find the rounded answer to the nearest degree. 6 different solutions to the equation of this guy. So if I were to go ahead and put this into my calculator, the arcsine of 0.964. So the arcsine of 0.964, control enter, I get this 74.5, 70, hold on, let me see if I did that right. Oh, 946, I see my mistake. So the arcsine of 0.946, control divide, and I get 71. So 71 is the angle that the calculator spit out. What is collinear with that? Or what is, not collinear, what is coterminal with that angle? So we know that the sine of x, whoops, get a different color. We know that the sine of x and we know that the cosine of x, they both have fundamental periods of 2 pi. So basically, if I wanted to find other angles like you see here, I'm just going to add increments or subtract increments of 2 pi. like 2 pi or 4 pi or 6 pi, because this is like saying this is 1 increment, this is 2, and this is 3 increments. And these values, we call them ends, if you will, as integer jumps. And then if I subtracted it, I could say that it's going to be negative 2 pi, negative 4 pi, negative 6 pi, and this would be like an integer jump of like negative 1, negative 2, negative 3, so on and so forth. You're going to see what that correlates to here very soon. Alright, so the same if I were to take the arc cosine of negative 0.5 with my calculator. So arc cosine of negative 0.5, control enter, I get 120. The reason why I get 120, again, is because it's lying in the restricted domain of arc cosine. So let me give you a quick visual real quick. So we know, unit circle wise, this is the domain of arc cosine. Is 120 in that? Yes, it's right here. So let's do the one that we did up here as far as with arc sine. We got 71 degrees, which is about here. And that works because the domain restriction of that is negative pi over 2 to pi over 2. And to save time, if I put this one into the calculator, it would give me a value of negative 45. And negative 45 is there. And the reason why it gives me negative 45 is because, again, from negative pi over 2 to pi over 2, similar to the sine, that's my restricted domain of the arc tangent. Now, keep in mind still that all these, if I took basically the tangents of them, they would all yield that same value of negative 1. But when I go backwards, and I'm taking the arc tangent, otherwise known inverse tangent, it's going to be only giving me that restricted domain value in quadrant 4. Okay? So real quick, now's a good time to state the following, is that inverse, let's say inverse sine of x, is the same as arc sine of x, is the same as writing it in this notation. Okay? But if I say, what is the inverse of sine of x? That is not talking about these three right here, because these three right here are looking for an angle. Inverse of sine is basically saying, what's the reciprocal? 1 over sine. Well, 1 over sine of x, by now you should know, is cosecant of x. So the cosecant of x is saying the cosecant of some angle will give an answer of some kind of side ratio. So I want you to know the difference right now, and make sure you're solidifying what is the difference between these two concepts and the different ways that you can write them. Alright, so a little bit of a review. If I'm looking at this and I'm reviewing as far as my positive quadrant 1 reference angles, I can basically use this one quadrant, so quadrant 1, to figure out any answer for any quadrant. Okay, so we're going to get to that here in just a bit. I just want to quickly review that to create these points, we know there's 3 of them. I will go up from the x-axis first, and that's on both sides, or I will go down from the x-axis on both sides. And I started off with 3, 2, 1 for the x values. Then I go back down 3, 2, 1 for the y values. So coming back down with the y values. Or if you're on the bottom, going back up, because you're trying to go back to the x-axis. Now, so looking at this, we've already discussed this in class a lot. The cosine value at pi over 6, here's pi over 6, is just saying what is the x value. Well, it's root 3 over 2. What is the sine value would be, whoops, let me do a different color. The sine value would be, what is the y value? And then finally, what is the tangent? Well, the tangent is the y over the x. Otherwise, 1/2 over root 3 over 2. Now, I know we've discussed this in class, but I want to make sure everyone has it. This is another way to write it. 1/2 divided by root 3 over 2, you've learned this when you were multiplying and dividing fractions, like in, what, 6th grade? 1/2 times the reciprocal would show, I got a 2 in the numerator, 2 in the denominator, they will cancel, so it's 1 over root 3. And then finally, I'm going to rationalize at this step by multiplying by a form of 1. Because I'm trying to get rid of this denominator of having a radical. So we know these two are the same as getting just 3, and then the top would become root 3. So that's how I get this root 3 over 3. If you need to pause the video or rewind, feel free to do so. And that's the same that I did on all of them. Let's go quickly to my last one. At pi over 2, which is right here, the cosine is the x value of 0. The sine is the y value of 1. But when I do the tangent on this one, it's y divided by x. I'm going to get an undefined because you cannot divide by 0. And it makes sense because the slope of a vertical line is undefined. It's the slope of a horizontal that's 0. And then anything in here is going to be a positive slope. And then, let's do this. Anything in here is going to be a negative slope. So, let me also show it over here. Anything in here or here have negative slopes. And anything in here and here, line-wise, will have a positive slope. The reason it being, if you don't know by now, is positive, positive, negative, negative. And then the other signs are different. Positive, negative, and negative, positive. Same signs will give you a positive slope. Alright, so enough of review. Let's go and now start finding, solving trigonometric functions when they're given to us like this. One method is to graph it. You see the graph of cosine of x. All I did was put in my calculator, and let me show you that real quick. I will put cosine of x. So cosine of x, and then I will put the other one of 1/2. So in y2 I put negative 1/2, and in y1 I put cosine of x. So I'm going to go to y2. So I'm going to press tab. I'm going to put negative 0.5, and I press enter. So this graph, these graphs right here, we already have on our piece of paper drawn for us, but I just want to quickly show you how you do it with the calculator. And we're basically trying to see when they equal each other. Well, when they equal each other, I've highlighted for you already here in orange at 1, 2, 3, x4, and x sub 5. So all these places is where they intersect. Okay, so looking at that, that's one way to do it. And if it asks me to find out all the answers, I could list them, but it would take kind of forever for me to do that. The algebraic way that I want to do that is I want to look at my problem and take the arc cosine of both sides. So I have cosine of x is equal to negative 1/2. If I take the arc cosine, it cancels this cosine. It's like undoing it, if you will. So what I'm really looking at is x is equal to the arc cosine of negative 1/2. That's what's simplified out. So for what reference angle is the cosine equal to a 1/2? Okay? This right here, I know it's negative 1/2, but this is a method of just showing you reference angles are always positive. And when in this quadrant 1 will my cosine, otherwise x value, be a 1/2? So let's go through this. 3, 2, 1. There's where it's going to exist, because the x value needs to be a 1/2. We know they're all over 2, and that's where I get this positive 1/2. So this reference angle is going to show an angle of pi over 3. So in which quadrants is the cosine going to be negative? Okay, I know I didn't write it here, but I only was asking it reference angle-wise. But my original problem says, when is it negative 1/2? So that's when we're going to incorporate this negative piece. Well, I know cosine is negative. Basically, the x values are negative in quadrants 2 and 3. Okay, so for what angles between 0 and 2 pi will the cosine of x be negative 1/2? Well, if I'm looking at this, it'll be 3, 2, 1, so it's at this one, and then 3, 2, 1, it's at this one. So that's why I have 2 pi over 3 written and 4 pi over 3 written here. But it's then further going to ask, well, which graphing solutions, x1, 2, 3, and 4, match these? Well, the ones that match them are x1, which you see that I highlighted in green. Sorry, not x1, x sub 2. And then x sub 3, which I highlighted here showing it on the graph in purple. Okay? So explain how to find the other solutions. So how would you find all these other solutions? Well, let's look at x sub 3. X sub 3, okay, is going to be right here, and you see that I've drawn what one period or one cycle would be to end up hitting x sub 1 over here. We know it's 2 pi radians because that is the fundamental period for cosine. So what I'm going to do with x sub 3, okay, which is 4 pi over 3, I'm going to end up adding this 2 pi n. Again, n could be any integer like -1, +1, -2, +2, -3, so on and so forth. Not 0, but all these other ones, okay? So n is, in this case, going to be a -1 because I'm going left 2 pi units. And when I do that, it's basically going to show that you can see over here that I've taken x sub 3 and I've subtracted this 2 pi to end up getting x sub 1. Now if I kept jumping over and over and over, left and left, I'm going to end up getting all these that pertain to when the graph starts going upward if you were reading it left to right. Now looking at this other one. X sub 4 can be solved when I take x sub 2 and I end up adding 2 pi. So I'm going to go to the right. That's why it's going to be a positive, and I would get x sub 4. So how could I do that a different way? Is that I can take this 2 pi over 3 and I can just do the same, plus 2 pi n. In that plus 2 pi n, because integers can be negative or positive, it's like saying plus or minus 2 pi n. Okay, but we're only going to write the plus because that integer can be negative or positive. It will take care of that plus or minus thing that is going on as far as accounting for jumps that are going to the right and jumps that are going to the left. And when I say jumps, I mean full period of 2 pi radian jumps. Why could the solution also be written as the following? From positive or negative 2 pi over 3 plus 2 pi n. Well, the reason of it being is that positive or negative 2 pi over 3 is also equal to 4 pi over 3. Okay? So let me draw this on the unit circle real quick. 4 pi over 3 is all the way to here. And then negative 2 pi over 3 is coterminal to get to that same point. Okay? So let's do another example. A little bit faster. It says solve the equation algebraically and use the inverse sign, otherwise known as the inverse sign or the arc sign. Okay? So what we do is we isolate the sine of x first, so that we have sine of x is equal to root 2 over 2, which if we're trying to find the angle, we take the arc sine of both sides. This is how we get this equation here. Now, we talked about this in class. If you can't understand that this is finding the angle and what angle that's going to be corresponding to on the unit circle, you can ask yourself, if it's in this form, what angle of x would yield a y value ratio of root 2 over 2? The reason why it's y value is because it's the sine, and sine is y. So what angle, when I take the sine of it, would give me a y value of a positive root 2 over 2. Okay? Positive root 2 over 2 says, because it's a y value, it could be in either the first or the second quadrant. So let me highlight that for you. The first or the second quadrant. Now I'm doing it slightly different to the way that I would prefer you to interpret it. That's a little bit different from this, but kind of the same, and you'll see how in just a bit. So I'm looking for, when is the sine a positive root 2 over 2? Okay, so here we go. 3, 2, 1, those are the x's, and they go back down. 3, 2, so it's going to be here. That's when it's positive. So 3, 2, 1, going back down, 3, 2. Okay, so there's the one that's important. So the ones that are important are here, whoops, let me do it in a different color, here and here, that denote that the positive y value will have a sign, or y value of a positive root 2 over 2. That's how I know I'm working with 1 and 2 as far as the quadrants. And the way that they were explaining here, well, what is the reference angle? The reference angle is pi over 4. Saying this is my reference angle if you were only to memorize the first quadrant. Now, you have to keep in mind that this will sometimes, this will always be a positive, but like we did in the previous example, our problem could actually be looking for a negative. So it's all about trying to find what is my reference angle and what quadrant am I in. So I will know how to extend those negatives and positives appropriately. So for what angles between 0 and 2 pi will the sine of x equal a positive root 2 over 2? Okay, this will yield at, we already see it on this, it's like I'm jumping ahead a little bit just to show you how I want you to use it, the pi over 4 and the 3 pi over 4, and explain how to find all other solutions. Again, the fundamental period for sine is 2 pi. So we're going to say plus 2 pi n. That means jumps to the right and jumps to the left. So it could be plus 2 pi n, plus 4 pi n, plus 5 pi n, so on and so forth. But if n was a negative 1, well, negative 1 times this positive would show a negative 2 pi, a negative 4 pi, so on and so forth. Okay? So if n is positive 1, 2 pi, 4 pi, so on and so forth, if n is a negative 1, it's going to be the negative jumps. So how many solutions can be generalized? Well, I will go from these answers and basically just add 2 pi in, because those are the periods of jumps that we saw from the graph on the previous slide. And how are the two solutions found using the inverse? Well, you're basically going to say that this pi minus this pi over 4. So you have pi, which is all the way here, minus this pi over 4, which is really going to be subtracting it from this quadrant, which show that it's going to be 3 pi over 4. Okay? Now, let's look at my next example. Now I'm going to, on this one, fully show you how I would solve it, instead of really following these, and then I'll refer back to these as far as how they relate. I would look at this, and I would isolate the tangent. And right here, I would ask myself, what y over x would yield a negative root 3 over 3? Okay? So what I need to do is, I need to think about, well, y over x, when is tangent negative? Tangent is negative when the signs are opposite. So I'm talking about quadrants 2 and 4, which is later explained here. So if I know that, I also have to ask myself, well, when do I have a root 3 over 3? Well, it's not going to be here when the x and y values are the same. Okay, so this is like an example here, showing that it's going to have a negative 1. And my shortcut that I showed you in class is this line is negative x. Y equals negative x. What's the slope of that? The slope is negative 1. So a good way, and this is only used when you're doing tangent. So a good way to know that you need something that is not 1 or negative 1 is that these two angles are the ones that are possible to create this ratio. So let's trial and error a little bit. 3, 2, 1, 3, 2, 1. We know this point is root 3 over 2 and negative 1 half. If I were to do a y over x here, I'd say negative 1 half divided by root 3 over 2, which is the same as negative 1 over 2 times 2, keep change flip if you will. This would simplify, those 2's would cancel, and I'd have a negative 1 over root 3, which simplified would become negative root 3 over 3. Not simplified, sorry, rationalized would become negative root 3 over 3. So I got it. I got the one that I was needing. And where did that occur? That occurred at 11 pi over 6. So the other one is going to be collinear from where that lies. So collinear will go through the origin, and it will be the other corresponding reference triangle, or corresponding reference angle of what this is, a negative pi over 6. But the reference angle is always positive, so we're going to say it is pi over 6. This is how I got my reference angle of pi over 6. So because of the collinearity, I know this is 5 pi over 6. That's how I have my other answer. The one that I saw for was 11 pi over 6. And from each one, from 11 pi over 6, watch what I'm doing. I could say, well, subtract 2 pi. Subtract another 2 pi. And you see me going clockwise because it's a negative. Or I could say, add a 2 pi from there. Add another 2 pi from there, so on and so forth. This is that plus or minus 2 pi n. Okay? And I can do that from 11 pi over 6, but I can also do that from 5 pi over 6. So here's an answer. I'm going to go the negative direction. So there's 2 pi. There's another 2 pi. And I'm just going to get all these answers that you would see that would exist on the graph that's similar to what we did right here. Like here, 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 so on and so forth. Those 2 pi jumps that you're doing. Now, I want to quickly show you, let me go back a little bit, that I can take care of all those answers simply by saying I can choose either one of these. And for example, I chose 5 pi over 6. And I'm going to add a pi n. A pi n because I don't have to go a full 2 pi in order to get all the answers. I just have to go half a pi because they're collinear and they will hit all the possible answers because they are collinear. And why does this work? Well, the reason why it works, it won't always work, but most of the time on these tangents it will, and you'll see how soon, is because of the fact that the fundamental period is pi. And on this one, it's going to be collinear. They basically happen every 180 degrees or every pi units. So when a special value k of the trigonometric ratio is given, inverse trigonometric functions can be used to determine a solution to an equation involving sine, cosine, and tangent. To write a generalized solution, generalized means takes care of all my possible answers, because I can't write infinite answers. Select the smallest positive solution, and then between 0 and 2 pi, and then we're going to add the 2 pi n, or we're going to add the pi n's because of the fact that it is tangent is pi, and the other ones are 2 pi fundamental period wise. Okay, so let's go now to the last couple of slides, oh actually the last slide, and you're going to see how I'm solving. So just like I was doing, this is how I'm going to talk you through this problem. I have my original problem. I get cosine alone, and I have cosine of this negative root 3 over 2. Now, I ask myself here, when is the cosine, otherwise known as the x value, a negative? Well, it's going to be quadrants 2 and 3. Well, when is it, again, the x value, because it's cosine, a root 3 over 2? So here we go. 3, 2, 1. So already I hit it here. Or 3, 2, 1. Already I hit it here. So those are two possible answers that I have. So I'm going to say the arc cosine of this is going to be either 5 pi over 6 or a 7 pi over 6. But something that I have to remember right now. The reference triangle, if I were to basically only think of this as being in quadrant 1, is a positive root, or a positive pi over 6. That tells me that because of this reference angle being a positive pi over 6, this is going to be pi over 6. Okay, if that is confusing to you, don't use that reference triangle. Just know that this is 5 pi over 6 or 7 pi over 6. Okay, and you have to use one of these that falls into the restricted domain of cosine, which is 0 to pi. 0 to pi. 0 to pi is that restricted domain of arc cosine. That's why I'm going to use this 5 pi over 6. And I'm going to use a positive. And I can say it's going to be plus 2 pi n. Now, that only takes care of all of these answers. 5 pi over 6, and then a full circle to the next. So that's adding 2 pi, adding 2 more pi's, adding 2 pi, so I've already added 6 pi, so on and so forth. It's never going to hit my other answers that are possible that lie over here with this 7 pi over 6. So how do we get that? Well, we could write 7 pi over 6 plus 2 pi n in addition to this positive 5 pi over 6. Or we could just say, because I know the cosine function is an even function, instead of going to 5 pi over 6, I could also say a negative 5 pi over 6. That's why you have this negative here, because cosine is even. That's why on the previous slide you saw that cosines had a positive or a negative, because it's an even function. Alright, so now let's go ahead and go to the tangent is 1. So the tangent of x is 1. I would say from here, some people would like to look at it also by saying x is equal to the arctangent of 1. But here I like to look at it and say, well, what angle that if I took the tangent, I would get a positive 1? Well, I know positives exist here and here for tangent because the signs are the same. 1 would be the middle one, when I know that the x and y value are the same number. So when I put them over the same, that root 2 over 2 over root 2 over 2, I'm going to get 1. Again, the shortcut is y is equal to x. The slope of that line is 1. So the 45's, my tangent's going to be a positive 1 in quadrants 1 and 3. Now, quadrants 1 and 3, from here I would ask myself, well, what's the domain of arctangent? Well, I know it's from negative pi over 2 to positive pi over 2, so the only one that would work, because right now I see a pi over 4, and I also see a positive 5 pi over 4, or I could say this is also a negative 3 pi over 4, but the only one out of all these numbers is the positive pi over 4. That's the only one that you see there. And again, I'm going to add a pi in because of the fact that these are collinear. Every pi that I go in increments, I will take care of all the possible answers. Next problem. Tangent's not alone. I got to get it alone. So I'm going to divide both sides by negative. So tangent of x is equal to negative root 3. When is the tangent negative? Well, it's going to be negative in this quadrant and in this quadrant because the signs are different. Now I need to find what angle, reference angle, creates this root 3. Okay? Tangent-wise, y over x. Well, the reference angle is pi over 3. Okay? Pi over 3 is basically 1, 2, 3 right here. So 3, 2, 1, and then 3, 2, 1. If I did y over x, I'm going to get root 3. But because I'm in quadrants 2 and 4, it's going to show that reference angle-wise, this would also exist in quadrant 2 right here as being 2 pi over 3. Or reference angle-wise in quadrants 4 would be 1, 2, 3, 4, 5 pi over 3. Okay, so why is it that I'm going to put 2 pi over 3? Well, the reason why I put 2 pi over 3, as far as my answer, is that, oh no, I just realized something. It's not going to be 2 pi over 3. Well, actually, it will. It's going to be looking at the solution between 0 and 2 pi. So that's a subtle thing that I kind of overlooked right now. So these two are possible angles, possible answers, but I'm going to put 2 pi over 3 because of the fact of it says to specifically put the smallest positive on this one. Now 2 pi over 3 plus pi n, because it's collinear, to take care of all those pi jumps for both sets of answers will work. But just so that you know, if this wasn't written and this wasn't written, well, let's say that this smallest positive solution wasn't written. You could put right here 5 pi over 3 plus pi n, and you would get the same answers. Let's say both of these were not written. Well, I know arctangent's domain is from negative pi over 2 to pi over 2, this angle that would occur coterminal with this would have to be only written as negative pi over 3. So if those two were not written, we would write it as negative pi over 3 plus pi n. So understand the subtle differences as far as what's going on there. Okay, but we're going to keep this slide, we're going to keep going based upon them being written. Smallest positive solution and from 0 to 2 pi. So let's get the sign alone. Sine is equal to negative 1/2. Sine is equal to negative 1/2 would show what y value would be negative. Well, it's going to be in these quadrants. And we need it to be 3, 2, 1. So 3, 2, 1, there's one of them. And then 3, 2, 1. I'm sorry, I'm doing the x's. I'm messing that up. So 3, 2, 1, and then going back up. 3, 2, 1 for the y values. This is whenever they're going to occur. So 3, 2, 1 for the x. 3, 2, 1 for the y. So we want it negative 1/2. So they are occurring there at 11 pi over 6 and 7 pi over 6. Okay, the reference angle is pi over 6. And I can get both sets of them because they're not collinear. I do have to list them out independently, and I will add the 2 pi n incremental jumps. Alright, so now we're getting a little bit in a groove here. Cosine of x is equal to root 2 over 2. And here's where I would ask myself, what x value, because it's cosine, what x value of root 2 over 2, what angle yields that x value? So it is a positive, so x values that are positive will be in quadrants 1 and 4. And we want to know when it's root 2 over 2. Well, that's going to be at the 45s. So it's going to be a plus or a minus pi over 4. Okay, because cosine is an even function. Just on the slide before, we showed that it was going to be a plus or a minus right here for cosines. And we'll say plus or minus 2 pi n. Okay, we have to list them both, otherwise we'll only account for the answers of one of these angles, like all the jumps that exist here over and over. But we never take care of this negative one. So we do have to make sure on these cosines to either list them both out or do the plus or minus pi over 4. So instead of plus or minus pi over 4, another way that I can write it is that one set of answers would be the pi over 4s plus 2 pi n. Or, still under this stipulation, I could say 1, 2, 3, 4, 5, 6, 7 pi over 4 plus 2 pi n. So I can list them both out, or I can take care of both of them by just doing that plus or minus. Now let's finish this up. We have sine, to get it by itself, negative 2 divided by negative 2 is 1. When is the sine value 1? Well, that will be at the 90 degrees. But that is not a reference angle. It's between 0 and 90, non-inclusive, that are only reference angles. So this is going to be pi over 2, but still it would be plus 2 pi n, because the fundamental period for sine is 2 pi.